Hello, welcome to this channel Chemistry Made Easy by Dr.ARM. Today we will see the next point and last point of this topic, that is ionic bonding and structure. The last point of this topic is percentage ionic characters of a polar molecule. So basically we are considering the molecule is polar in nature, and in such case we can find out the percentage ionic characters present in it. So the percentage ionic characters in the molecule depends upon two factors, that is, this depends upon two factors. One is the difference, that is Xe minus Xb, that is electronegativity difference of the two bonds. Then it also depends upon the dipole moment of the bond of the molecule, you can say. So we will see the first factor, that is E, that is difference in electronegativities. Difference between electronegativities of bonding atoms. Here we know that the greater the value of this difference, that is Xa minus Xb, so the value is greater, the percentage ionic characters are more, means the bond is ionic in nature, or it has more ionic characters. So we can say that the bond is polar, it is more ionic in nature, and in such case the percentage ionic characters are calculated by using Pauli's equation. We can calculate these values, ionic characters, by using Pauli's equation. Pauli's equation. So this equation is like this, that is percent ionic characters equal to 1 minus e raised to 0.25 into Xa minus Xb. So here we can find this Xa minus Xb, that is difference between electronegativity values of bonding atoms. So this will give us the values here. So we can compare these values. We can say when the Xa is, we will see the data. So if we write here Xa minus this Xb equal to, and here percent ionic characters. So we can show these values in this direction. So when the percent Xa minus Xb is say 0.6, the percentage ionic characters are 9. These are 9%. If the value increases to 1.0, 1.0. The percentage are also increasing, it becomes 22. Again, if the value xa minus xb increases to 1.4, then this percentage and characters are again increasing, continuously increasing, it becomes 39%. Again, if the difference, electronegativity difference goes to 1.7, the percentage of ionic characters goes to 51. Again, if the value becomes 2.0, the percentage characters are increased to 63. Again, if the difference goes to 2.4, then the percentage ionic characters are increasing to 76. Again, if the difference goes to 3.0, the percentage is increasing to 91. And again, if it becomes 3.2, the percentage characters are 92. So in this way, you can compare the electronegativity difference and percentage ionic characters. So using these values, we can compare the percentage ionic characters. Now we will see the next point of this, that is dipole moment. Dipole moment, that is mu. So we have seen that the mu is calculated by using Q, that is charge, into L. So we know this formula, and using this formula we can calculate the dipole moment. If it is calculated in this way, it is called mu calculated, and we can obtain the mu observed values. Mu observed values. So these are observed experimentally. So experimentally the values are shown in this way. So here mu observed is smaller than the calculated values, and it depends upon the ionic characters. Means when ionic characters are smaller, the mu observed is also smaller. So mu observed and ionic characters are comparable. Now here we can find the percentage ionic characters with the help of these two values using this formula, that is percent ionic characters is equal to the ratio of these two, that is mu observed upon mu calculated into 100. So this gives us percentage ionic characters of covalent molecule. Initially we have seen that the molecule is covalent, but we are considering the percentage of ionic characters in such covalent molecules. So this is the formula. We can explain or use this for or study this, you are taking some example. So if we take the example here, that is in case of HF, for example, in case of HF molecule, hydrofluoric acid, here the bond length, that is L, the bond length is equal to 0.92 angstroms. It means it is equal to 0.92 into 10 raised to minus 8 centimeter. Then it has charge, that is Q. The charge is Q, that is Q is equal to 4.8 into 10 raised to minus 10 raised to minus 10 ESU, electrostatic units, ESU. Here the observed mu observed is equal to The observed value of mu is given as 1.98. 1.98D. And we have to find out the percentage ionic characters from this. So first of all, we will calculate the mu value for this molecule. So using this formula, we can calculate the mu value, that is calculated mu value, as we have seen that the mu calculated is 0.92. Mu, formula is same, so we can calculate mu calculated is equal to, what is Q? The Q is like this, 4.8 into 10 raised to 10 minus 10 ESU into L. What is L? It is 0.92 into 10 raised to minus 8 centimeter. So this, if we calculate this, it gives us, or we shall make it short, 4.8 into 0.92 into 10 raised to, we can add this, it becomes 10 raised to minus 18. Here we know that when, that is 1D is equal to 1 into 10 raised to minus 18 ESU. One D is equal to 1 into 10 raised to minus 18D. So it gives us if we calculate this gives us 4.42. The value is 4.42D. 4.42D. Because this 10 raised to minus 18 becomes D. So this is our calculated mu. From this we can find out this value. So we use here the value. The mu observed. What is mu observed? The mu observed is 1.98. 1.98. And mu observed is 1.98. And into this 100 upon mu calculated is 4.42 into 4.42. If we calculate this, it comes out to be 44.8. 44.8%. So the ionic characters in HF are 44.8%. So in this way we can calculate the percentage ionic characters for various molecules which are dipolar in this way. Then there are some other factors which are also determining or responsible for the ionic characters. These are hybridization of atomic orbitals of the central atom. Similarly, the direction of lone pair and also the contribution of total dipole moment of the molecule. So the net contribution of the total dipole moment is also varying. So with this we will stop here. We have completed this topic today. Now and in the next lecture we will begin with another topic, that is atomic structure. So till then, goodbye. Please subscribe to this channel. Press the bell icon button and like button and put your comments for further guiding. So see you next time. Thank you very much.